back to this project we're working through in Common Lisp. Last week we had a look at introducing a jump or a goto, and then some sort of conditional if. And I mentioned last week that we would start looking at adding in comparison operators this week. That's exactly what we're going to do. We have equal, not equal, greater than, less than, less than, equal to, and I'm not going to implement all of these. I'm going to implement maybe half and leave the other half for you to complete during the course of this week if you want to give that a go. And next week we'll fill them in and see the solutions to those and how to use this very strange looking programming language we've created here to build up all of these concepts together to write a very simple program that will in fact be Turing complete. Now let's just get into this. And we're going to start our equality operators with 301, since we had our arithmetic with the 100s, our jumps and gotos with 200. I believe since we're starting a new concept here, a new range of numbers would be entirely appropriate. So what we are going to do is we're going to have a wee think about this. What would be a good thing to do? So this is going to be our equal. So I've just thrown this together very quickly. So we're going to check that the value stored in 2 is the same as the value stored in 2, which it will be, and we're going to store that in 3. And if it is true, it will write a 1. If it's false, it will write a 0, and we will move on and jump to that 0 there. So we're going to have one that works and one that doesn't. So this should be the same. That would be a 0 instead. So obviously we don't have this working yet, but we've seen this kind of thing before. There we go, so we get our two numbers and we write it out to the destination. So we'll say if equal num1 program and nth num2 program, we're going to say setf program counter no, we're not. We're going to setf nth dest program to be 1. I've written that equality symbol there, function, method, whatever you want to call it, and we've recompiled our code. So we have our example here, and we got 3012210, which is exactly what we'd expect, and this was 3011210, which is not what I wanted. This would be a 2, this would be a 4, this should be a 0. 2, 4, 1, 0, why is this? So look up the value stored in 2, which is 4, and look up the value stored in, that is 3. Oh, I have a typo here. Did you spot it? Did you wonder what I was doing there? Because I totally missed that. There we go. So 2210, 3012210, which is what we want. Hopefully this will be 3012410. Two four two zero. That's a bit strange. Oh, again, another typo. That's what we want. 2400. Yes, so this should be 3012400, which is exactly what we want there. I do apologize for not seeing that. It's been something of a long day. But there we have our equality function, for lack of a better term. So this is going to be our not equal. And I'm going to leave this one up to you, a 302. So this isn't going to do anything yet. And let's just have a think about what we want our things to be. So it should be exactly the same, but this should be a 0. So we want to check the value stored in 2 is not the same as the value stored in 2, and then write out to 3 there. So we should actually get 2200 there. So we want to check that the value stored in 2 is different from the value stored in 3, which is 2. So 3 and 2 should be not equal. And we're going to store it in 2, so this should become 2, 1, 2, 0. So if my understanding is correct here, that's what it should look like. So you have the opportunity here to create a not equal function. And we are going to move forward with a greater than and a greater than or equal to. So we're going to write these two functions out here, and then you can write out the equivalent less than or less than equal to. So you will have up to 3 things to play about with this week. So in our greater than, I'm just going to copy this. Totally paste it into the wrong place, of course. I'll confess I have a wee bit of a headache. It's not been the best week lockdown wise. It's been pretty stressful, so do apologise if I make some very elementary mistakes here. It's just been a bit of a tough week, but we're doing alright now. So we've got our greater than, and we know in Common Lisp we have our greater than symbol, and it's going to behave exactly like these. So I'm just going to copy these. I'm going to paste them down at the bottom here. This is going to be a 303. There we go. So we've got our greater than. I've just compiled that up. So I would expect here that we will write 0 here because 1 is not greater than. So we're going to check to see if the value stored in 1 is bigger than the value stored in 2 and store that result in 3, which should be 0. And then the inverse should be checking to see that the value stored in 2, which is 1, is greater than the value stored in 1, which is 2. So no, this is not going to work. So we're going to have a look at the value stored in 3 with the value stored in 2. That's probably closer to what we want. There we go. So I'm just going to evaluate this now, and I got 3011200, which is in fact what I expected. So we're looking for 303. I do apologise, I've not updated the comments there. 3033210. There we have it. We've got that working now. So we can see that our greater than is working. So we're just going to copy this and we're going to update this to a 304 for our greater than or equal to. So we want to see if the value stored in 1 is greater than or equal to the value stored in 1. We're going to store in 3. So this should be a 1 because they are equal. And we're going to say the value is greater than or equal to so it should be 1 3 0 0 if I've got my understanding correct here. And I've just created those stubs there for less than and less than equal to for you, just for when you get around to doing this. And of course, really the only thing we need to change is that. So I run this now and do a 304. Oh yeah, apologies, that comment is not quite right. That is a 1, not a 2. So we got 304 1 1 1 0, which is what we want, and we want 304 4 1300, which is exactly what we get here. So we're proving that the value stored in 1 is not greater than or equal to the value stored in 3. So we now have these in place and working. Now, I am sure you can look at this and have a pretty obvious understanding of what those 3 missing methods are going to do, and that's fine. It's just there for you to just interactively follow along, because I imagine it is far more rewarding to actually write your own code rather than me give it all to you. And I've just realized that that early issue, my interpreter was telling me I wasn't using num2. If I'd only just looked to the right, I would have seen it, but never mind. So once we have the not equal, the less than, and the less than equal in place, which you'll hopefully have done by next week, we will then, as I mentioned at the beginning of the video, start looking at how to build loops and things like that, because honestly, once you've got those functions in place, we have everything we need for a Turing complete language. It won't be intuitive to write programs in this. As you see me, I'm getting mixed up and getting it wrong occasionally, but that's not the point here. The point here is to see how little language and syntax there is actually in a Turing machine. So I hope that has been interesting for you. Just a reminder, again, I have this competition running. I know I've gotten more subscribers. I appreciate every single one of you subscribing. If you want to be in with a chance of winning Land of Lisp by Konrad Barsky, it's a great book. It's really fun. I highly recommend it. I've got a competition running. There will be a link in the description. If you want to give it a go, I will send the book to the winner. But thank you very much all for engaging and staying with me on this channel. I cannot thank you enough. Please look after yourselves, especially if you're in the UK with these new various tier 1, 2 and 3 and what's going on with that. Thank you for watching. I will see you in the next video.